So I like to just read a little bit here, because I want to make sure that this I say, because then I'm just going to go all over the place, and I just want to make sure I get this stuff out. So when the Jesuits got to Japan with the Portuguese, they were interested in the arts and culture, and, you know, it was a very weird place. So they visited the master of a school of sommeliers, kind of like ink kind of painting. So it's a, you know, painting school. After some tea, a Jesuit priest asked the master, "What is the hardest thing in your form of painting?" To which the master replied, "What to leave out." So I guess it applies not only to sommelier, but it also applies to history talks, and come to think of it, programming language design. I also want to apologize from the get-go for all the people that I'm leaving out of this talk. And I can see a bunch of them are sitting right here. You know what, let's just name some. There's Joe Sachs, who's a player in this drama, and David Weiss, and Stephen Apter, and Mike Wilson. There's a lot of people here, and they're not going to be on the charts, but they played a very important role in all this. I did a lot of research, probably too much research, looking at the history and everything. And I was able to verify maybe 80% of the stuff. There's some things in here that you're not going to be able to find on the web. And as I was looking at it, a lot of memories started flooding about all these people that are no longer with us, that has such an incredible impact on this whole vector programming tradition. And going back to, you know, I don't know, those guys, like the guy who wrote the Rhine Papyrus in Egypt, all the way, you know, to people like, you know, Ken Iverson and so on. And I just you know, want to give my thanks to all of those people, and the ones that, especially the ones that aren't here, and, you know, may their memory be for a blessing. Okay, so this quote is from Ecclesiastes. There's nothing new under the sun. And the second quote is from Arthur. I mean, he actually did say this. Probably true. You'll see why I put this up as kind of like prelude to the whole talk. And now, go through this order. Next one. So, again, I just want to make the point that this is my very subjective look at the world, and it's a lot of people may totally disagree with it. So I'm not suggesting by any means that this has any actual objective truth to it. There are two big ideas in API. And the first one is a tool for thought. And this is out of the master's, you know, mouth. And here, this is from a paper that he wrote on exactly by that title. Tool for, you know, APL, tool for thought. And I'm going to read it. As Babbage remarked in the passage cited by Cajori, brevity facilitates reasoning. Brevity is achieved by subordinating detail, and we will here consider three important ways of doing this. The use of arrays, the assignment of names to functions and variables, and the use of operators. And brevity, I mean, it is what Iverson wanted. Iverson wanted terseness. Iverson wanted exactly what we got. There's another area which may be more implied, and that is universality. So if you're reading a paper on quantum mechanics, and, you know, it's maybe written by Schrödinger, he's going to have a certain kind of notation in it, right? And it may be different than the one that some other, you know, physicists might have. And usually that's not too bad. They're still using powerful notation that allows them to express themselves, you know, clearly in the subject matter that they're talking about. So the translation from one to the other is not that big a deal. You know, so summation is using a sigma, blah, blah, blah. And you can kind of get it very easily. And, you know, you make the transition and you can exploit the slightly different variation in, you know, in the other mathematical notation. But when you get to executability, when you're running on a computer, right, then things change, you know, because now you would like things to be as universal as possible so it can be shared. And so you want to get some sort of agreement. And I think that Iverson was very keen on making that happen. And so he did a lot of things that bring that stuff together. And I think a lot of his creativity and a lot of his contribution has to do with taking this notation, which is this historical thing that that starts. I mean, APO starts 2,000 years ago before. The second idea is more about implementation and not language definition. And that's basically the greatest idea is space over 6. What is it in APO? Is it 6 or 3?
6.
6. In K, I think it's space over 3. And basically what that signifies is some sort of dialogue. You do something, the computer does something back. It's the concept of basically what turns into an interpreter. And as you start doing the interpreter, you start doing other things. I don't know if some people remember in APL, you had all these wide parentheses message commands that basically are subsuming the things that you need as an individual to do operating system kind of things. So the whole idea, of that whole APL environment, which is a complete time-sharing user environment, was to be able to solve problems without any intermediaries, without IT, without anything. You could just get in there and start doing your work and go all the way to the end. And that idea is super powerful. Now, arguments have been made that I thought that APO was the first place where a practical interpreter, used for commercial or useful things, was built. But it turns out that there's a parallel development occurring in something like Lisp. And so a lot of these things were either invented separately or they were shared from the 1950s when a lot of these ideas were made. And so once you get to time sharing, which is a person can get access to a computer and they can exchange messages with others and they can run stuff, that leads you to things that presage the PC. Because PC, you may not be able to, in the beginning, you wouldn't be able to communicate with anybody else, but you were able to solve problems that you can contain within your own machine. And then the web is a way of doing it, with the shared thing, and already the time sharing thing is basically a web, a proto-web, and the concept of the cloud, because your data was sitting not on your computer, but sitting out there in the cloud. So all these ideas are very old, and that's why I'm saying there's nothing new under the sun. That's an example of what I'm talking about. I think this is profoundly important, and it's a contribution, given by APO. Okay, this is true bullshit. Okay? What I mean is it's completely my own crazy way of looking at it, and a lot of people will try to decompose, programming language history or whatever in different ways. I believe, from my point of view, there are 3 traditions in programming. The first one, in my opinion, starts with Gödel. The concepts of recursive functions, the whole formalization, like the whole concept of Gödelization, which is taking something and reflecting it as a number, the whole concept of encoding. He did a lot of work in that area, and the whole concept of formalizing something so that it's very, very precise. So I like to put that guy as a real key person in it. Of course, Turing really took that thing and turned it into a almost visual way of representing the stuff with the concept of the Turing machine, and I won't waste your time with that because you know what that is. Then von Neumann, who, by the way, knew both these 2 guys. Von Neumann was at Gödel's talk when he did the first incompleteness theorem, arithmetic, the incompleteness of arithmetic, and he figured out what the problem was, and he went and talked to his teacher and told him that his program, that his program was kaputt, as they say in German. So almost all, and von Neumann did a lot of things, but he also did the stored program computer, and the whole idea of a computer with registers and so forth. The whole design is not very different than what he did. I would say, wouldn't you say that most of the programs, most of the computers today are basically his architecture? Basically, yes. Okay. All right. The second tradition is this guy, Alonzo Church. He came up with, the lambda calculus. It's a kind of like a more bizarre, different way of defining what computation is. And languages like Lisp and Scheme and the things that are heavily used in artificial intelligence and expert systems come from that tradition. I'm not going to spend a lot of time on it. It's a very powerful tradition. I put it here because, in my opinion, my experience with Lisp is completely orthogonal to APL. Completely, I mean, pretty much. And then we get to Iverson, and Iverson is basically mathematical, the history of mathematics. That's where it comes. And if you want to know where it leads, well, a lot of these languages, K, KDV, J, A, I didn't even put A in here, an A plus. But Mathematica draws, maybe 1/3 of the language is totally founded in vector programming. And it exists today, and it's fairly vibrant. In MATLAB, in the sense that, if you know linear algebra, they taught the computer linear algebra. You can do linear algebra stuff, so it's kind of that tradition. Spreadsheets, in my opinion, have a lot of that flavor. Because you have columns. They're really basic scaling, but there's a certain relevance of vector languages. Okay, next. So here are the guys that I was talking about. Gilbert over there. That's Beardo. I like to go over here, though, because this is the one I want to really focus on. So I'm just going to start with Euclid and Archimedes. So Euclid gives you geometry, and we all know about how we formalize stuff and so on. So I've got to give this guy credit for notation and stuff. Archimedes basically invented integral calculus. I don't know if you guys know. Does everybody know who Archimedes is? Has everybody heard who Archimedes is? So, I don't read this. Can everybody hear me?
Yes.
So, they found a palimpsest. Palimpsest is a animal skin scroll. And palimpsest is something that's like reusing it. You scrape off what's on it and you write something on top of it. So they found one that had some Islamic writing on it, but underneath was in Greek. It was a treatise by Archimedes. And up until that time, everyone knew that Archimedes knew something about taking volumes, because he figured out all these, give you answers for these very crazy volumes and everything. But that palimpsest describes basically integral calculus, kind of to the level of Leibniz and Newton. So just to show you how far back an idea, can stretch. It's also had the Antiquity device. I'll tell you why that's in here. And that's also another issue that I want to get into, which is universality. There are writings that describe this machine, or a machine like this, in Archimedes' writings about Archimedes. So it's possible that he designed this machine. Antiquity is an island in Greece, and they found in a boat that had sank 100 BC. They found this machine. It was all kind of crudded up with 35 gears. And it's only been recently with X-ray and fancy technology that they were able to figure out how all the pieces really were hanging together. And it's got 35 gears, and it's basically an analog computer. 35 gears in Antiquity, okay? Just think about what that means. They all have to work together, and they all have to grind in the right way. Nobody believed that it was possible before the industrial, before the 1700s, right? Nobody thought that anybody could do this. Well, there it is, and it works. And people have actually, I've seen it, if you go on, there's a lot on this on the web. You can see that they've actually made a Lego model of it. A very complex, Lego model. Basically, it was used to predict the position of the planets as they were known at that time, the number of the planets that were known at that time, and predicted eclipses, and it had dials, and it was just unbelievable. So at any rate, the question that I say is, if such a device, so complicated, existed 100 years before the Common Era, why didn't people make more progress? Now, I'm going to go one more step here. This is the Jacquard loom. And the Jacquard loom is general in the sense that what it does is it has hole punch cards, right? And you feed it the cards. You put the cards in these cords, and you run the cards, and the cards basically do the design on your carpets or on your textiles. So if you want to change it, you want to reproduce another carpet, you just take the deck of cards representing the way the machine has to do the things. This is a very complicated machine, probably from the 1800s. I'm not sure exactly the date. What? In the 1700s, there was this incredible exploration of mechanical toys. I mean, orchestras, you know, they're all organized and orchestrated, and the guys would sing, and people would sign things with the machines. It's indescribable, the level of detail that you know, a level of sophistication. For example, music, you know, piano rolls. That's a very, you know, low-tech, you know, example of things that involve coding and involve, you know, mechanical computation. You know, of course, you have Babbage, who, I mean, he's a loser because he couldn't even implement his own thing. You know, I wish he had, you know, but in Leibniz, I mean, Leibniz built calculators in the 1600s, and they were being used in the 1800s as design, and well, we'll get to him in a second. Getting carried away. I mean, these people really, you know, really inspired. But my point is, why didn't people come up with a computer sooner? Is what I'm saying. Forget that, you know, 1900s. Why didn't they make a computer? There is a science fiction book by a guy named William Gibson called The Analytical Engine, and the whole premise is that Babbage gets some funding, you know, and he builds the computer, and it gets driven by, you know, by a steam engine, and they have a, you know, security, you know, social security system in England, you know. I mean, it's also a crime whodunit kind of thing. But my point is, it could have happened. It really could have happened. And it, you know, I mean, it's mostly a lack of imagination, a lack of, you know, taking the idea to its ultimate degree, and probably not enough will or desire to do it. Because I mean, what do you think is the largest building before the Eiffel Tower? What was the tallest human-made structure in the world? Yeah, that's from 3,000 years ago. People wanted to do it, and they did it. So anyway, I don't know. I think a lot of it has to do with context and sociology. All right. So we have Al-Khwarizmi. By the way, the word algorithm is from his name. And he's, an Islamic mathematician that came up with a lot of what we call algebra today. Leibniz. I didn't have to do all the Leibniz separately. The reason why, besides the fact that he's such a maven, so we find a binary system, prolific inventor of mechanical calculators. You can read it, but this is really cool. Leibniz saw symbols as important for human understanding. He attached so much importance to the development of good notation that he attributed all his discoveries in mathematics to this. His notation for the calculus is an example of his skill in this regard. So that's why he's on this list as one of the in the hit parade. And of course, these guys, pretty obvious, Kylie and Haley and Sylvester, they did the Matrix thing. I don't have enough time. There are lots of stories. This guy was a real piece of work. Is dueling good or bad? I don't know.
Your wire is disconnected.
Your power.
All right, the power's gone, so I got it about an hour. Hopefully for you guys. Way before that happens. Okay, so now we're going into modern times. So I skipped very fast. You know what? You probably will know all of this. How many people know everything I've said so far?
Everything?
Most of them. But you don't know some of these things. Well, okay, so Iverson, I don't know how they met, but Iverson and Ian Whitney was Arthur's father. They became close friends. After Iverson came back from he was in the Air Force, the First World War, Canadian Air Force. He came back and went to college. I don't know where they went. I don't even know if it's possible they were both in Harvard.
They met at
They met actually at Harvard. Okay, good.
They both won a Canadian math prize together to Harvard.
Very cool. And Ian Whitney has the highest score recorded. I don't know. At least certainly up to that time in the Putnam test. Got the super smart guy. He died young, unfortunately, and so Iverson became sort of like a little bit of a father figure for Arthur, and sort of stepped in for his friend, and they had a long friendship always. And so there's a lot of direct influence in more than just technical or mathematical stuff between these two guys. 1948. Joel is born in Cuba. For 20 years, misses a clue embedded in his last name about the row vector language. I don't know. Somebody pointed this out to me not that long ago. Okay, so I'm not going to go into a lot of detail about this, and you can find a fair amount of it on the web. All the wheelings and dealings going on at IBM and the research centers, and I mean, I know all about it, and I could really do it, but you're all going to kind of fall asleep, and we'll not move from here, and I don't think it's really relevant. But a lot of ideas were worked out. What virtual memory, the role of virtual memory, the role of virtual machines, all these things were worked out, and how to utilize them in systems. I mean, and I don't mean just a little bit. I mean, to the same level of necessary. They figured it out completely. If you were to go into VMware today, and you compare that to IBM's VM, CP67, I don't even think, he was telling me VM can't virtualize itself. You can't run a VM thing, the hypervisor, under itself. Maybe that's not true. Maybe they do it for themselves. You would think that they would do it for themselves, right? But they don't make it available. What, do you care? You don't want to have VM under. Do you want to have VM? Why would you want to have VM under yourself? All right. Well, they probably do. But I'm saying, the point is, this is a solved problem, and I'll go a little further. I might just go right in. I was a systems engineer in IBM. And IBM had these different operating systems. And they hadn't even figured out how the hell am I going to move from one operating system to another operating system, to different kind of hardware, and so on. This VM thing saved their butts. Because they could buy whatever machine they were on, they could run the VM and run the code that they would, let's say they were on DOS, disk operating system. They wanted to go to MVS or MFT. They would run both these things together as VMs, exactly the way we do today. And if that hadn't been there, there would have been no way to convert from one to the other. Remember, computers are really super expensive. And so, I mean, I know this firsthand because I was a systems engineer, and part of my job was to do these kinds of things. All right, I went too far on that, but I think it's an important point. Okay, so, from 61 to 67, all sorts of different versions and things go on, and a lot of it's the scientific centers. I mean, MIT got really pissed off at IBM, and they made a big split, because IBM, these guys that we're talking to, didn't believe in virtual memory, and they said, we're not doing time sharing or any of these ideas without virtual memory. And IBM had this dog, that they had this thing called TSS, that never worked, and they put hundreds of people on it. I don't think there's ever been more than 10 people that ever worked on any APL system. I mean, people that actually do stuff. So they get the first implementation going, and it's this thing called, so I just told you, I found this thing in the University of Florida. My first programming course, when I learned Fortran, was one of these VM systems, and each one got in there. Again, that wasn't really an interpreter, you have to compile the code, but I learned Fortran. So 1969 is a key point, and I really do want to take a second here. But before I go there, I want to tell you what the argument is. I'm going to stop this guy. Escape, right? And I want to just put this guy up. All right, I kind of like this one. Hey guys, are you bored? I'll stop. Jean-Claude Keely's career is going down there. I want to read this. Okay? This is me and Bruce Cousins with our doggy match thing, going to the Miami News newspaper. This is actually reprinted in some other Podunk, Arizona, or whatever. By the way, Google had all these things. You know, they've been collecting all these newspaper things. And moving right along now, we head into the 1970s. This thing was in January 1970, where they computerized doggy dating service. The founders of this service came to my office with a computer. Nothing personal, I had asked him to actually, and basically I didn't want to know anything, absolutely nothing about computers, helping dogs along life's lonely path. On the other hand, I figured I would worry more about it if I didn't know. My whole life was like that. He said it was pretty good, actually. My feeling was that if a human accomplishment had culminated in a mechanical brain click-clack genius and throwing some lecherous colleague in with a potential score at better than house odds, quite as a man that he should be proud. They should be proud. I'm a reactionary about dogs. When it comes to advice for the lovelorn, if a dog wants to be popular, let him do it on his own efforts. The name of our firm is Dog Image. Said a young man named Bruce Cousins, who appeared with a large computer on a cart. Consider this is actually happening in 1969. He rolled the article afterwards. Computer on a cart, plugged it in. It was a huge DocuTel acoustic coupler thing where you connected it at 110 baud through by dialing a phone, and the thing went, you know, that's what that was, and it was huge like this. But again, think about how advanced that was, walking into a guy with basically, you know, computer. Computers were like as big as this room there, right? Who appeared with a large computer on a cart and plugged it in, diddly dip, went to the computer. I see, I said. My partner Joe Kaplan and I, he said, are industrial engineering students at the University of Miami. We do this on the side. Joel Kaplan, I said, looking at the machine, diddly dip, zoop. Joel Kaplan, doggy needed a boyfriend. You've got her, Mr. Right on tap. The computers are programmed with complete banks of information we gather from many sources. Who said, we'll find your daughter maid and add her name to the listing for future reference. She's an Italian greyhound who likes culture. And he's obviously trying to be really funny. Look, Bruce said, I don't want to mislead you. We will add any psychological traits you want to, of course, but this service actually is to furnish immediate data of a physical nature. Keep listing of owner's whereabouts and where are you going. I asked as he handed the computer my telephone. It fitted into a slot in the machine word, preparing a holiday message for our clients. He said, I didn't press the matter. Joel Kaplan came in, a tall young man wearing a guru jacket and a quizzical expression. So you can tell what year that was. How did you get the idea of a computerizing doggy information? I asked. Can you think of anything more appropriate for computers to do? Joel said. These things scare me silly. I like the idea of matching doggies by computers. It puts the machine back in its place. Yep, Bruce said. Machines may rule the world before it's all over. Right now, we've got them mating doggies. As they left with the large computer, we shook hands wordlessly, the three of us. Yeah, you wonder, why am I even wasting the time? Consider this. It's a time-sharing system. We're at a location wherever we want. I mean, this is like, it was unheard of, right? And it was all possible. We did it all with APL. Remember what I said? End to end, you don't have to have IT, you just log in, boom, whole thing. So I thought I would point that, read that little article. We didn't make much money. The draft came along, we had other considerations. Vietnam,
Satisfied customers?
well, we would go to dog shows, and people would come in and we'd do matches, and matches, build a database. But you could actually go to an actual dog show and have your computer there. This is like 1970, right? It's all based on APO. There's a colorful character. By the way, I'm just trying to give you colorful stuff. I mean, this is not a technical talk. All right. How did this happen? There was a guy named Brooks White. This is the guy that you're not going to hear about. Brooks White was working for a guy, and they got a copy, this is 1960, for them, 1969, of APL 360 on their DOS. It was object code. I don't know how the hell they got it. I mean, it was a product. I don't know how they got it. They were running it on a model 36030, which probably is 1/3 10,000 for the power of this. And they were trying to do a time sharing system based on APO. And we were doing our stuff on PO1 at first, you know, and we just had cards and we were doing it on a computer and you know, in the university we had a little account. And we ran into this guy and he showed us APO. I said, well, look, we can't pay you, but do you want to go in business with us? And the guy says, why not? You know, they have plenty of capacity then. And I thought, well, they have plenty of capacity anyway, so we went into business together. And they gave us 2 of these DocuTel thingies, you know, with the typewriters and the APO typeballs, and it was like amazing. I had learned a little Fortran, and all of a sudden I could solve problems, and I couldn't understand how the 2 things could exist at the same time. But back to this guy, Brooks. This is a fun guy. He was a dropout from Duke, really great programmer, and he was an anti-Vietnam guy. I mean, he was actually, I don't even know if he was he was a real left-wing communist kind of guy. But you would never believe it. He was so, you know, looked so normal, sort of like you. I'm joking, please. Underneath, behind those eyeballs, there's really weird things going on. Anyways, this guy, you know, this guy, so in 1973, IBM announced, one of the big flaws with this whole thing is that you couldn't communicate with the world. A lot of the things that have been enhanced over time is the ability to get data from some places and communicate between processes and everything. That wasn't really possible with the first APO, the one that we were using. This guy, when that first thing came out, he wrote an auxiliary processor, sort of like inter-process communication today, to connect an APO workspace system in ABC or CBS, I don't know, CBS, to predict the election results as they were happening in the night. You know how we get into trouble. That the first system ever to be done, and for a couple of years thereafter, was based on this thing. This guy Brooks made a lot of money. You could imagine how valuable this thing is. So just so you know, our election forecasting systems were based on APO. He later became a treasure hunter, and he hit the mother lode. He found a galleon, a gold galleon, you know, Spanish thing, off of the, Florida, and it took him quite a number of years, you know, because you get the government, they all want to take up their piece or whatever, but he became very, very rich and totally fell out of it. Do you remember Brooks? Does anybody here remember Brooks White? Okay, so he remembers.
I worked with him at CBS.
There you go. So am I right? Have I said anything to, you know, disparage
At the time I knew him, he was already doing this treasure hunting thing. By that time, he looked like a long-haired beach boy.
Okay, okay. But anyway, I tried to find nothing on the web. So this is one of these guys that if it wasn't for, you know, Chris Lincoln here, you would think I'm a fool or whatever. So that's, sorry, it's not very much of a vector language, but let's see how much you can, I'm not going to waste some time here. Okay. Forget all this stuff. Here, IBM 5100. Anybody heard of the IBM 5100? The first personal computer, commercially available personal computer, ran APO. In fact, it was designed to run APO. I'm not going to go into the details. And then they added BASIC, and then they marketed both of them and whatever. The computer was about this big. You can look it up on the web. It's about this deep and about this wide. And it had a little screen, and it ran off a tape.
And a little switch, by the way.
And a little switch. Boom.
It's up for basic and down for...
Yeah, exactly. In my case, it was always welded shut on the I had the privilege of getting one of these machines as a systems engineer in New York City because IBM was being sued at the time. You know, antitrust. And they had so many witnesses and so much stuff to keep track of that they wanted somebody to do that. And they actually gave me one of these machines so that I could program this thing. And I mean, I did this on my spare time, but it was fantastic. I mean, today, you know, it's laughable, but you know, in those days, everything was with typewriter and papers, and you know, it was very anti-ecological. You know, I mean, then I became the first class, so about 50 of us, IBM salesmen that only sold software, and they called us the drag iron boys, or girl. I don't know if there was any women some, but the idea was they don't they didn't give a hoot about selling a piece of software for 120 bucks a month or whatever. But they wanted to have the things that chew the most CPU. And so somebody convinced them that you ought to have software guys because they'll drag the hardware along. And that was a good idea. I was one of the first guys, and my job was to sell APL products. And here comes a very important thing, because it basically presages the application that KX and 1010 Data really, made really big. So there's this thing called I'm not going to go into VSAPL and all those other things for that. This ADRS was basically not a very good program. I didn't like the way it was designed. But it was basically, it was a spreadsheet with columns, and you could specify columns and stuff. And you got through, you did it via time sharing. So that was a very popular, before PCs, it was a very popular application, even though it was a little bit cumbersome. There was another one called APLDI, and the guy who wrote that program was a guy named Corey Fair. I don't know whatever happened to him. It's one of these guys that there ain't very many things on the web about. APLDI was an amazing thing. It's basically KDB and what we do here at 1010 Data. The whole thing was vectorized anyways, and so, and in fact, there are a few functions in APLDI we still don't offer. But it let a person load up some data. There was a loader in COBOL that loaded this stuff in and kind of like segmented it. It was an inverted data structure, of course. And then you could do selections and sort, and you could just do APL in there and, do databases and link files and whatever. It was so unbelievably popular. IBM ran hundreds of and he built this for internal use, You would not believe how important APL was to IBM. Today, you don't even see it. There were hundreds of mainframes dedicated completely to APL time sharing. And people that were using it were basically end users, people that have problems to solve. Like I wanted to figure out how to lay out, my chips on an assembly line or whatever. Every financial guys, every conceivable kind of guy that had a real problem ended up. IBM had internal APL conferences that had 1,000 people attending for, 20 years. There was also the external ones that people know about. There were internal IBM APL conferences that were being held. This is all going on. I don't know where IBM would be without it. Today you go, you look at it, it's all gone, and it's like as though it never existed. This APLDI was one of the major things. People would analyze, do their analysis with it.
Now I'm going to get to, what about Bloomberg? You had the last one here. What was that? Michael Bloomberg.
I'll tell you about Bloomberg in a minute. Oh yeah, actually, I'll tell you right now. As a salesman, my job was to try to sell across in my region, across all the branch offices. So what I would do, I had this thing that I would do. I would ask some person to say, "Give me your data," and they would bring a tape. Somebody would bring me a tape like a day or a few days before, and we would load up the tape into APLDI, and then we'd invite a bunch of people, and then we'd ask them, "What would you like to know?" And those were enormous databases in those days. I think I once did 86,000 records in one of these databases. I mean, it was unbelievable how big that was. Bloomberg, Michael Bloomberg was working at, what's that brother, Solomon Brothers, before that. And he was basically what he used to be before was just a bond trader. And he got the position to be head of IT. So, IBM would suck him into going things, and he ended up going to these things. And he's sitting there while I'm doing, it was some other app, it wasn't a financial application. And he's looking at, he comes up after me. I remember, I don't know what he looks like now, but he was redheaded. And he comes up to me, he says, really with an intense look, and he says, "Is this for real? Is this really work? Are you joking around with me?" I mean, it was like, I said, "Hey, nothing up my sleeve, But he very, very intense and very interested, I mean, obviously he left before, you know, any of this thing turned into any kind of business. I mean, I wish I did. But I remember how intense the guy was about whether this worked and it didn't work. And then, of course, then he went out to do the whole Bloomberg, you know, system, which is, you know, fantastic product. Okay, so let me go again with this. I'm going to bang this APLDI hype thing again. We get to Morgan Stanley. There's this guy, Bill Cook, some of you know him, blessed memory. I had a love-hate relationship with the guy. Really smart guy. He comes in and he says, all this bookkeeping that we're doing, all this back office stuff really sucks. So he brings this thing called database, which is supposed to be a relational database thing. And he does the applications. He has all these smart kids doing it. He loads all the data up, and now he wants to ask a question. He can't get any of this stuff to work. It's too slow. So I'm talking to him. I says, you know what we should do? Give me your table. Come here, and we'll unload all this data from your, you know, mainframes, and we'll put it into APLDI. And then you can ask any questions you want. There are at least 2 people in Morgan Stanley in the accounting area that became managing directors because of the benefit that Morgan Stanley got. And we bailed his butt out because otherwise they never would have had any way to do analysis. Again, it was so successful that we actually made an internal version of this thing called Hydra. You're not going to be able to find anything on it at all. You can find a lot of Hydras, but not this kind of Hydra. But it was, and actually this was written by Rommel Lefkowitz, for those who know. And this thing was used all over the firm, and it made really head. The other thing I wanted to point out is there was a machine called the APL machine. It was a company called Analogic. I just want to show you about it. Nothing new under the sun. This thing in 1975, the AP400, was a GPU. And you plugged it into your whatever computer you had, and when you want to do operations, you know, through libraries, you sent it down there and it did it. So I'm just trying to point out that, GPU is really a new idea. The guy was trying to sell stuff, and he knew that APO was vector-oriented and everything like that, so they built this machine. Let me tell you the problem with this machine. Everything that went into, they had an interpreter in front of it, and then they would zip things into, you know, the primitives were supposed to be done in the back end. The machine was 100 times faster when it was doing some primitive like inner product or some kind of, you know, heavy-duty vectorial thing, or a sword or grade or whatever. It was an absolute dog on anything that had to do with interpretation or looping. And the disparity was so high that it was unusable. Remember, we tried to do something, and does anybody remember this machine? You try to do anything, and it goes boom, 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 and all of a sudden, it takes forever. So it was unbalanced. And by the way, Arthur Whitney's, one of the design goals that he told me is all operations in the language are within one order of magnitude, from the fastest to the slowest. The fastest is no slower than, the slowest is no slower than 10 times slower than the fastest. Because otherwise, the program, the system is unusable. Because just when you hit that, that bottleneck, you just kind of like die. So anyway, that's what our experience was. We had that installed for a little bit. Then, of course, the PC came, ADRS, rolling out, and went to VC Calc, and those 1 to 3 in Excel. And that took a lot of air, oxygen from APL, because now most of the simple problems that people had, 90% of the problems were very simple, and they could do them locally on their own machine. And so that took a lot. And you might almost say that the vector language sort of died into the whole spreadsheet game. All right, now we'll get to the analytic proprietary trading. How many people here are in hedge funds or things like that? You don't want to raise your hands at this point. So we had a hedge fund. I ended up running this thing. It was a long and short portfolio, and we took cheap stocks, whatever that means, and we bought them and we shorted long stocks, and we did this all mathematically, and we pumped the orders right into the exchange. Now, so thousands of people do this today. First of all, it was really hard because the exchange wasn't set up to take those kind of volumes, and in the beginning we actually had to print the orders at the post, and people with brokers had to go run around, whatever. But it got a little better even, at this point. But anyway, we were doing this on the mainframe. And this Irvin Gillespie Berger guy, actually he was a classmate of mine in Cuba. He was a IBM corporate vice president, so there was maybe 10 of those guys. So we're not talking about VP the way it is now, we're talking about serious dude. And he ran all scientific computing, and the IBM machines at that time had vector processors. So when I said, hey, look, why don't you make the vector processor an APL talk more? Doesn't that make sense? And so he did whatever he could, and he pushed the guys in the APL thing to make that thing go as fast as but it was impossible. We needed to move to workstations because these things were shared resources, and you couldn't change anything because you affected too many people, and so it wasn't really applicable to a trading operation inside of Morgan Stanley. So we knew we had to move to that. So a bunch of the people that were in that group. Well, Arthur Whitney, the interviewer Arthur Whitney, he comes in, and we were doing some nearest neighbor techniques, trying to find out some sort of distance between things for recognizing certain kind of patterns. And we're having a hard time doing this in APL. So we presented the problem, as soon as he comes in, he says, what the hell, he's supposed to be a smart guy? Wasn't he, when we asked him a real question, an answer would be useful, I kid you not, his eyeball went down up to the right for went like this for about 15 seconds. And he went up to the board and he wrote 6, I wish I had them, 6 APO characters. They absolutely nailed, the nearest neighbor point. I said, let's hire this guy. By the way, he was hired at the research. Arthur Whitney was not doing technology. Arthur Whitney was there, programming, but working on strategies and things like that. He's very good at that stuff. Mueller, I'm going through a list of people who were in that group. So Eric Mueller has just won the Feigenbaum Award. That's the most prestigious award for artificial intelligence because he was working on the Watson Jeopardy system. But what's incidental? He wrote an APL interpreter, vectors only. The whole interpreter was 5,176 complete APL that you can do for vectors. 5,176 bytes. And he did that in 1977. Then David Shaw. Everybody knows David Shaw here. So David Shaw was the guy who did was basically running technology at the time. And he was doing all sorts of neat things with allowing it, all these machines that never worked, but at any rate, he did put a lot of effort into them. And then, of course, he left, and he did very well in trading, as we all know. Robert Fry, who you don't know, probably, he came from Harris. He's a really smart researcher, loved APL. Harris also had an APL, it's not only IBM. He left, and he went to work for Renaissance. He did the Medallion Fund, and that Medallion Fund started at $100 million. And it ended up over $5 billion. He's very. I think he may be worth more than this guy. But anyway, he now runs. He does a few little things, but he runs the Stony Brook Financial Engineering Department. People that help work with us. Mandelbrot, who's trying to work on some of these chaos ideas. He didn't call it chaos, but fractal ways of looking at the problem. Shlomo Winograd, who invented the fast Fourier transform algorithm and ran mathematical sciences. Because we did a lot of fast Fourier transforms to try to find the shapes of things, and I don't want to get into it. But anyway, John Koch, the guy from RISC, who invented the whole concept, is credited with the RISC thing and the IBM machines that. AIX or Unix systems, whatever. He's the father of that. By the way, he loved APO, and he loved what we were doing. He said he had a southern accent, very national. He says, "That's the way. That's the way computers ought to be used." We had a guy named Leon Cooper who had a company called Nestor. He was the Nobel of Physics. And it was basically neural nets, but he had a different kind of scheme. And it was faster, but very smart guy. And we gave him some spreads to see if he could figure out what was going on. And he did. I don't think it was his technique, it was that he's a real scientist, you know, and he knows how to, you know, do research, but, you know, this company really figured that out. And then a bunch of guys that did, you know, a lot of optimization stuff. Philip Wolff, he's an interesting guy. Philip Wolff helped us to write a fast quadratic programming algorithm for APL. He's at Yorktown Heights. So I'll tell you a story that people don't know. Everybody knows Harry Markowitz, the guy who was big, won a Nobel Prize in, you know, economics, for microeconomics and stuff. He invented the mean variance method for portfolio op, the whole big bullshit in finance. He's the guy who invented it. So you know how that started? They were both in Yorktown Heights. Philip figured out how to do convex programming. And he's talking to his buddy, Harry Marcus. He says, what can we use this for? He says, oh, maybe we could use it for, you know. And so he basically kind of, you know, the two ideas came together. I mean, nobody knows Philip Wolff, but everybody knows Harry Marcus. Okay, Bill Gates, this is a cool one. So Bill Gates came to Morgan Stanley. We brought him, Morgan Stanley have brought them public. And you know, it's obviously trying to sell more stuff. And this is around the time of Windows 3. This is like really like the early days of this stuff. And he's trying to sell everybody on the idea, hey, you know, this is a great system. And he'd come to Morgan Stanley, and he talked to a lot of IT guys. I wasn't at that meeting. I came to the second meeting where now he's giving his pitch. And so I started, you know, going there. So I said to him, why should I go with a closed system? You know, meaning this, you know, he said, well, our system is compatible down to the hardware, which is true. I said, but you control everything, you know. I says, and so we started arguing about that. And I said, why shouldn't I go with Unix? And in those days, there was no open source, there was no Linux, it was like BCD. What did we ultimately do in Morgan Stanley? Was it Berkeley? Unix, or whatever, one of those.
Sun OS.
What?
Early Sun OS.
Yeah, so we were arguing, and all of a sudden says, what do you do here? And I said, well, you know, I run this, you know, technology for this group called the APT, and, you know, we use APL. And we've had an APL written for us, this is A, that we use here for doing the trading. He says, APL? But I mean, son, APL. He said, but that can't work. It's an interpreter. It's slow, isn't it? And I said, not ours. and we had a back and forth. You know, this conversation, just between him and me, went like for 20 minutes. And he looks to the left, and he has a guy there with, like, sort of like, in Jobs also had a guy like this. He had a little thing, it looked like an, you know, like packing something, you know, like a fence kind of guy. But he also understands technology. So he said, you gotta talk. See, I didn't give a rat's ass about, you know, kissing butt, you know. I mean, I was working for Morgan Stanley. Today, I mean, I would have been going like this. But then, I mean, I'm not gonna profit from it. You know, we're doing what we're doing, who cares? I mean, in fact, I don't want other people to have, you know, A or whatever. But anyway, he looks at the, turns to the guy and he says, you should talk, please, go follow up with this guy afterwards. Later on, I find out, and I can demonstrate, I don't want to bring it up, documented from a letter, you can find it on the web, where he was working on an APO interpreter. That's what, you know, this is after they get their little, you know, OS, before they did BASIC, he was working on an APO interpreter. I don't know what happened. I mean, presumably he tried to sell it, and there it says, that's Chinese, you know, little characters or whatever. And he being a good businessman, went for BASIC.
Paul talked about it.
So anyway, who knows what would have happened if it hadn't been that way. I mean, there's just too much going on. How much time is it? Over?
No, I mean, 15 minutes.
Okay, one more. I'm just going to skip along this stuff. There's one more story here that's also worth talking about. Let me do this. Arthur says, forget IBM, they're not going to solve your problem. I'll write you an interpreter. So now, this is a pretty hard thing for somebody to tell you, right? I mean, Morgan Stanley is a financial house. We don't have all the capabilities of whatever. So I went to David Shaw, who was really smart. I mean, had a compiler company before he did stuff and whatever. And he said, Joel, by the way, Shaw respected APL, but his head says, he says, Joel, my head doesn't work that way. I have to have loops and I have to have, scalars. That's the way my head works. So just to show you, there's a lot of ways to skin a cat. He told me not to do it. He said, it's too many people, it's too much support, it's not something that a financial, I can do this on the side. And I took it seriously. So I went to IBM and I said, I want to talk to the language labs. I want to know what actually it takes to do these things. And I went to the Fortran thing and they had like 50 guys. And that was not as applicable. Then I went to talk to the guys. Peter Hertan, the guy who ran the APL thing. And this is what I find out. They have, 10-ish kind of people on the APL team. They had 4 different environments that they had to run it in. And you had to have a plug to plug each one of them. So there was one guy to interface it, the CICS, the TSO, the VM, blah, 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 blah. And so there were all these different things. So that takes care of 5 people that aren't dealing with the language. They had people that had to support this thing with the field and people, to answer questions and all kinds of things that I really wasn't going to have a problem with. So I took care of another 2 guys. Now we're down to 7. And documentation guys or whatever. So now we're down to like 2 guys. One guy who wrote the code and an understudy who did a little bit of coding, but it was kind of like backup in case the other guy, decided to disappear. And then I said to myself, it's like always, it's only just it's like Pareto's law, there's only a few people that do the really good things. And that's what convinced me to go ahead and do this A thing and let Arthur do it. I mean, we did a lot of work on, they actually changed hardware in IBM based on our suggestions. Remember the paging stuff? They had a dumb way to do it, and we convinced them that they should have a different way to do it like everybody else. And they did that. And then A+, which I don't want to get into Apple stuff, is putting a GUI on A. That was all done afterwards, when Arthur had left, and we had 500 Unix workstations deployed for the fixed income research, for the fixed income side of the house, all over the world, and it was all running A+. Roger Hugh, incidentally, for those of you who Jay, worked in our group with that also. Atlantis software. See, people don't know, they keep thinking of KX. Before there was KX, there was Atlantis software. And that's under that, game, K was, we all went to UBS. David Weiss got Arthur come in and work, and let's make this thing, really production. We did a lot of stuff in UBS. And it was great. I mean, we learned a lot, and we can go into the details, but there's not going to be enough time. I can also tell you lots of stories about Switzerland. But anyway, I spent a year there one night.
Writing a project plan.
I can't, there's so many stories, but they're not related to Jobs is really interesting. Jobs was in Next. He had already made his investment in Pixar, so he didn't even realize how rich he was going to be. And just maybe 6 months from going back to to Apple, he was talking to the financial community because that's where they had the most traction with the Next system. Does everybody know what that is? It was some computer, and then it was bought up by Apple. So we went to his pad, the company pad, and it's on 74th Street in Central Park West. It's phenomenal. It has these 2 towers.
San Remo Tower.
Yeah. And Bruce Willis and what's her name, G.I. Jane. They had one tower, and this is another tower. Really cool. We had all these stodgy IT kind of guys. It may have been like 12 or 13 of them, and like falling asleep on his talk. And afterwards, he says, "Let's go to dinner." And so we go to dinner. All these people. There was only 3 people that wanted to go to dinner. Bill Cook was one of them, and me. We had dinner with basically a table, me, Bill Cook, Steve Jobs, and some other guy, another ear kind of guy with the kind of guy, And he looked great. They're both very different. Gates, his shirt's like this, and his hair's like that. But Jobs was, in those days, he was very healthy, really, with a turtleneck, and, it's just really, anyway. We spent a couple hours, and we were talking. So I'm gonna tell you what he said, what the conversation, because part of it is related to in those days, there was this blight on the world called object-oriented programming. and you know what? There is a role for it, but I never understood what the big deal was. I'm not going to get into that. I guess what they wanted, the idea of reusability, and that everything is just like engineering, there's no art at all in programming, it's kind of appealed to management. And so that they did all that. Anyways, okay, it's not a bad idea. It's not even wrong. It's not even bad. It's just...
Just apply it.
So he had this thing called Objective-C, and he's describing to me how we operate. Now listen, very intelligent. He says, the guys, and he was mentioning the guys that we had in UBS, that crew that blew up all the money, you remember the guys, Hadar, the other guy. Hadar, yeah. So basically you use Mathematica and you prototype your ideas and your trading, and you can connect it to the system in various ways. And once you've got the strategy and you know now that it works and that it's worth implementing, then you go and you program it, you get the real programmers, and you translate and program it into Objective-C. Now you got a system that really helps. So I was telling him, I said, look, what if you had something like Mathematica or whatever, suppose there was something that you can prototype and do all the stuff, and then you don't have to do anything else. It just runs. And he immediately says to me, no, it's not possible, interpret it, no, it can't be done, And I don't have anything to, what do I get ready? And he looks at me, he says, do you have something? So then we got into a conversation about, what we're doing with K, the actual possibility of something that's interpreted really running fast and whatever. We had a long conversation. And then he turned around to the guy with the pack and says, please get in touch with these guys. But of course, his life kind of totally exploded after that. And I never heard from him again. He also told me about an object-oriented programming, one thing that he did say, which is really worth mentioning. This is what he said. He said, the first time you build a system, and you're talking about the hierarchy, the thing that's supposed to be reusable, the first time you do it, you barely can figure out what the hell's, you're trying to figure out what the customer wants. And if you're lucky if it works, it's just like a prototype. You don't even know. The second time you do it, by then, hopefully, if you've done it right, if you're in the right process, at least it will do what you need. It'll actually perform the functions, but it'll be too slow and it won't be really the right thing. Now, once you got to the second stage, now if you go to the third stage, at that point you can make it so that now you understand the problem completely, you restructure the damn thing so that that hierarchy has value and it performs really well, and now you got something that you can say. So it just goes to show you the difference in thinking. This guy was a smart guy. I mean, he understands what the actual process is. And by the way, out of all, I met McNeely from Sun, and he didn't know anything at all about computers, zero. He didn't, but an interesting guy, right? We were at that meeting. But these two guys, Gates and Jobs, for whatever it's worth, they understood the problems that they were dealing with, and they didn't need anybody to interpret it for them. And I'm not trying to take anything away from Steve Ballmer, but it's not the same kind of thing. And I can tell you, those guys really knew what they were doing. I said 15 minutes, 5 minutes. Powwow. It's too long, I'm getting tired. Well, we did this thing with the Zurich group, and basically trying to do insurance, figuring out the value of an insurance company with Monte Carlo or whatever. We did all the stuff, and we decided not to play ball with these guys. They wanted to keep the IP, whatever. I don't know. We just didn't want to do it. Sandy and I didn't want to do it. To me, the whole thing is science fiction. David, you know what I'm saying? It's like the simulations, the numbers, whatever. Can you try 100 times to see if it's stable, if the mean is the same? And he said, 100 times. It's going to take a while to do that. So anyway, whatever. So we left there, and we left with one little piece of code, which is the part that goes in and it gets the data out of, back to APLDI, the little tape guy in the scientific center, You take the data and you suck it out from wherever it is, and you invert it and you load it, and then you can crunch it down so you can put it into the math model. That we kept all the other mathematical stuff we let go. And so we're saying, what do we do with this? And they gave us money, they gave us most of the stock back, and that's where, David and us parted ways, went, in the other direction anyway. So we're sitting in Palo Alto, in Arthur's house. Sandy, myself, and Peter, who's another of the guys who was there. And we came up with the following idea. We'll do it on the cloud. And we call that Yadata because, Google didn't exist then. So basically the idea is that you would do for tabular information what they do for search. And we would make it a service. So why should everybody have to do all the stuff? We'll just do all the heavy lifting for you. And we'll do it on the cloud, which is basically back to time sharing. And that was our idea. And everybody says, oh, what visionaries and whatever it is. But this idea, just sitting around thinking about it, it's all based on the vector model. Everyone realizes how these simple operators are so apt for the database problem. I don't have to kill this into the ground. Find, the question mark each right. I don't know what it is in Q right now. Probably that idea exists there. And all these things like just the concept of indexing and the concept of selection and linking and all that kind of stuff. It's just like a natural. So that's why we went with 1010 data, and that's what we are today. And that's the end of my story. Thank you very much.